This video is part of the ADS-B Link Augmentation Press Kit.
This engineering video was produced by ADS-B Technologies for the exclusive use of its clients. These tests were performed in the vicinity of Lake Clark Pass, located approximately 130 miles south-southwest of Anchorage, Alaska. During the tests, all aircraft were significantly below the line-of-sight horizon for the ADS-B ground-based transceiver located at Merrill Airport, Anchorage. This test began at the eastern approach to the pass. Due to moderate crosswinds and turbulence, the minimum altitude was 400 feet AGL. We're now approaching a particularly hazardous part of the pass known as the Narrows. The Globalstar link to the ADS-B ground station is active, and a simulated controller back in Anchorage is now following the flight in real time. Notice the close correlation between the space-based ADS-B report and the actual aircraft position. WA's GPS accuracy is a nominal 30 meters, and the latency of the report is less than 400 milliseconds even without dedicated telecommunications links on the ground. Because we still have snow cover, terrain details may be difficult to see. Follow the action and see if you can pick out the small glacier just off your left wingtip. Notice that we're flying on the right side of the canyon, and indeed, the controller's view also shows us on the right side. The canyon is only 300 meters wide at this point. Now watch as we execute a left turn into the main part of the pass. After the turn, it's almost due west for 45 miles into Lake Clark itself. This will conclude the first portion of our correlation test briefing. In the second half of this video, we'll examine multiplane correlation and how it might apply to separate criteria between aircraft. Although this demonstration was flown at a mountain pass, the same results are achievable virtually anywhere we fly. In the middle of an ocean, mid-continent Africa, or through the Himalayas, it makes no difference to our space-based ADS-B system, supported by Globalstar's reliable next-generation constellation of low Earth orbit satellites. Now let's take a look at the system's ability to resolve issues of aircraft-to-aircraft separation. In this first example, we have two aircraft flying in close formation. Each aircraft has its own ADS-B system on board, and each is reporting to an ADS-B ground station via a Globalstar satellite link. Latency is a very important factor in any frame of reference involving two or more aircraft. With the Globalstar system, we're dealing with latencies of less than 400 milliseconds. 400 milliseconds latency combined with the great accuracy of ADS-B also means that the system is capable of supporting en-route separation between aircraft down to as little as 1 mile. Now, we'll test the system's ability to handle the dynamics of high closure rates. This will be a 3-mile setup with a 100-yard left-to-left pass. A white aircraft against a white haze will be difficult to see today. Closure rate between the two aircraft is about 5.5 miles per minute. Now let's zoom in to about 2 miles for a closer look at this head-on pass between the two aircraft. The circle represents a 1-mile radius around the camera aircraft. At about 3/4 of a mile, our target aircraft should become visible in the red diamond. And finally, here's a pilot's eye view of the last half mile. This concludes this test and evaluation video. Any technical data in this video may be exported only in accordance with the U.S. International Traffic in Arms or Export Administration regulations. Unauthorized use is strictly prohibited and may be unlawful.